All right, so another way to solve systems is with elimination. So before we get started on that, um, I want to go ahead and answer these blanks for you. So a coefficient is a number that's in front of a variable. So for example, the 3 in 3x is a coefficient, okay? One that I talk about a lot is 1 in y. So there is a 1 in front of the y, and that is called the coefficient, okay? Like terms have the same variables, or variable, to the same power. So for example, 3x and 6x are like terms. Or you could even get fancy and say this group of variables is a like term to that group of variables too. Okay, so we'll be adding like terms a lot today. So yes. To get us started for elimination, you can see the rules here, so I encourage you to read those, scan through those. But I want you to look at this example. How do you add equations together? And why are we allowed to do such a thing? So we're going to be doing this today, just like slapping a plus sign there, putting a line, and then adding down like this. Add these together, add these together, and add these together. It's completely legitimate, but I wanted to help you understand why that's the case, because at first it's like we've never done this before, so we should have a sense of why it's true. So if I ask you to add 2 to both sides, this is like my sketch of a proof of an equation like this, like plus 2 plus 2. Like if we were, it wouldn't really be getting us closer to solve for a variable, but let's just say that this is something I wanted to do. Is this legal to add 2 like that? Yeah, it's legal. It's the same quantity, right? Equations are balanced, so as long as we add the same thing to both sides, it should be fine. But when we added the equations over here to the left, we added 2 to the right side, but we added negative x, negative y to the left side. Okay, so why is that allowed? Well, look at that second equation. It says that 2 is the same thing as negative x, negative y. So can't we just, instead of adding 2, can't we just add negative x, negative y? And is it still balanced? It seems fine to me. Okay? So by adding equal things to both sides, we don't disrupt the balance at all. But now we've kind of shown that you can add 2 equations together because you're still adding the same thing to both sides. They're both equal to 2. 2 is 2 and negative x, negative y is 2. Okay? So that's the motivation of why you might believe adding equations together is valid. Okay. So let's just jump in and solve a system. So for this sort of thing, we want this behavior to happen here in yellow, where x minus x equals 0, a cancellation. That's where elimination comes from. So we have to adjust the coefficients in an equation so that we get elimination happening. So for this one, a good choice would be, there's always more than one choice, by the way. But I'm going to go ahead and multiply by minus 2. So top equation is unchanged, but the bottom equation, I'm going to distribute the minus. Right? And that's that. And now we have opposite coefficients, we'll call them. The 2 and the minus 2, right? If I add down, I just get 0. Okay, so it turns out that y is 3 because you divide by -1, right? And this 0 you can just boop, toss out. Okay, and then it's just like substitution. Plug that back in to anything that's typed on the page. Doesn't matter which equation you pick, you'll always end up getting a solution once you plug back in. That's elimination. That's it. So the tricky new part is this first step of how do you know when you're at this step? What do you multiply by so that you get elimination? That's the tough part. Okay. So those are the steps. They're written out here for you. Okay. Let's do this again. So let me try and talk you through the process of knowing what to pick to multiply by. I always look for multiples. So like I know that if I count by 2s, 2, 4, 6, I see that I have a 6 there. So maybe if I took the first equation and multiplied it by 3, triple it, let's see what that does. Copy down the other equation, and voila, we have a 6 and a -6. So those are going to cancel, which is the whole point, because when that cancels like that, see, this is 9x plus 0 minus 18. When that cancels like that, we can solve the equation, right? 9x, that's got to be -2. Okay. So, and then you just have to, I'm going to choose the second one just because we haven't messed with it at all. So I'm going to leave space. That's where my newfound x is going to go. Okay, so -6 is the result there. I'll go ahead and add 6 to both sides, and we get that y is 3. So 2 examples worked out of how elimination works. Okay. Let's go down here to Blake. So Blake has some $1 bills and $5 bills. He has a total of 15 bills. That's $47. How many of each type does he have? It seems like a question we should be able to answer, right? But it's not obvious. So I'm going to let, as always, we want to establish some variables. So x is going to be the number of $1 bills, and y is going to be the number of $5 bills. Okay. So x plus y should be the total number of bills, right? Which is 15. So just like that, we already have half of our system made up. Okay. The other equation's got to use 47 somehow. And x and y, of course. So having one $5 bill is better than having one $1 bill. So I know I'm going to have to take x and y and multiply them by something to like show their worth, right? Like, for example, if I had like, let's see how many dollar bills we can make here. Let's see, something like this. So an example, right? If I have two $5 bills and three $1 bills, I have what, $13? The way you calculate 13 is the answer to this, finding the rest of this system, right? So if you have 3, this is X, right? You have 3 of those bills and you have 2 of these bills. So if you want to try and get 13, you have to say that you did at the $5 times the Y, so 2 $5 bills plus 3 $1 bills. So in other words, if we put a 5 there, that tallies it up correctly, right? If we just focus on this expression, when I increase X by 1, I get $1 more. When I increase Y by 1, I get $5 more added to my total. Okay, so we have to adjust for that. Yeah. So these are my 2 equations, and I like what's going on here, but one of them should be negative, we have to be able to add down. So I'm going to change my first equation to be a negative X, and with that I have to change everything else in there. And then I'm going to add down from here, which gets me 0 plus 4y equals 32, and y is 8. Okay? So if I have 8 $5 bills, and I have 15 bills total, right, so using this equation and this equation, I should be able to figure out how many $1 bills I have. I have 7, because 7 and 8 make 15. And bam, done. Okay? 3 questions left. This is a question about milk and cookies. So let's say that it's asking for the cost of milk and cookies, basically. So if we let M be the number of, be the price of milk, and let C be the price of cookies, we have to figure out 2 equations that have 19 and 14 in them, right? Those are the 2 costs. So our equation should reflect that. So look here when it says 2 gallons of milk and 5 packages of cookies. If I'm the cash register and I'm ringing that up, I should do 2 times the cost of milk, 2 gallons of milk, plus 5 times the cost of cookies. Okay? And the second instance, the second checkout is the price of milk plus 4 times the price of cookies. Okay? There we have it, 2 equations. What do I multiply by? Well, again, looking for multiples, I can see that if I multiply this by 2, it'll match the 2 above. So I'm going to choose -2. So my 2 equations going into elimination will be these 2. So it takes repetition, practice to see this, and you have the homework to work on to achieve that. But that's the choice, -2. Because now when I add down, I'm going to get an equation with no m's. The m's are gone, they're eliminated. and divide by -3, I'm going to get 3. And then I'll take this answer and plug that into an old equation I made. So milk is $2 and cookies are $3. So it must be a big package of cookies and probably less than a gallon of milk. $2 is pretty cheap for a gallon of milk. But yeah, it becomes an elimination problem. We could also use substitution if we wanted to. Should get the same thing. Okay, and then I just want to just briefly talk about these. These are our special cases. So how do you get a cancellation here? We'll pause the video and think about it, and I'll tell you. This is the equation with the smaller coefficients, so it makes sense because you multiply this one up, and to get to 30, I have to multiply by 10. So this is 30x minus 10y is minus 50, and then my other equation rests right beneath it. And if I add down at this point, I get something pretty crazy. All zeros, everything was eliminated. Oops, right? But this is good. This is good because if 0 equals 0, this is a true statement, which means that no matter what I pick for x, I'll be able to find a y that makes it true. So this is our infinitely many solutions. Because, and to support that, these are the same equation. Right? These two guys right here, they are the same equation. One of them is just multiplied by -1. And when you have equations that are identical stacked on top of each other on a graph, going back to 5-1, infinitely many solutions, they overlap everywhere, right? So a lot of ways to support your answer of why this is infinitely many. And then this guy, again, the top equation has smaller coefficients in size, so I'm thinking we should boost this up by multiplying, how about by 3? So I get this as my top equation, and my bottom equation is the same. Add down, and look, we got all these zeros again. But over here we get 16. So my final answer, I guess, is 0 equals 16, which is nonsense. That's not true, never true. And if we tried to find the solution to this system and we got and we found out that process, it's never true, no matter what you do, we can't make it happen, that would mean no solution, wouldn't it? So these two lines are actually parallel. They never touch, there's no solution. Okay, so practice these examples if you weren't here. Please show me your homework if you finish it. But these will give you more practice on thinking, what do I multiply the 1 by to get an elimination vertically. I feel like once you get that step down, the rest of it